Today we will be discussing a tutorial recitation questions as per the SR University. In the in the last session, we have discussed about what will be proposition and what will be predicate and logical connectors. Now we will see some of the real-time problems, how they involve in reality, and then we will find the solution for that. So ఇప్పుడు మనం as per the SR University ప్రకారం recitation questions answers discuss చేద్దాం. So the question number 1 is so the question number 1 is identify whether the following statement is a proposition statement is close the door and justify your answer and justify your answer. So the answer for this is, let us try to discuss. So ఇప్పుడు ఇచ్చిన స్టేట్మెంట్ ప్రపోజిషనల్ కాదని ఐడెంటిఫై చేసి మన యొక్క ఆన్సర్ని జస్టిఫికేషన్ ఇవ్వాలి. సో we'll try to discuss the solution. Generally, after looking at the sentence, let us say the sentence has given us close the door. The sentence, the proposition is given us close the door. If you see here, this sentence has the usually what is meant by proposition? A proposition meaning is either it should be true or false. So the statement should be able to be either true or false. But here, if you see, it is look like some sentence, but it doesn't have any kind of truth values. It doesn't have any truth values, like either true or false. So this is an imperative sentence. So this is an imperative sentence. So like commanding, you can see the close the door. This is commanding type of sentence. So that is the reason this is not a proposition. This is not a proposition. So we see the second problem. The second problem is let us try to have Question number 2 is, let us see, translate the sentence translate the sentence into into logical form. Translate the sentence into logical form. The sentence is, if it is raining, then the ground is wet. So now we want to transform the given sentence into the logical form. The logical form, as we discussed, so ఇక్కడ మనం ఏం చేయాలంటే లైక్ ఒక సెంటెన్సెస్ ఇచ్చారు, దాన్ని మనం లాజికల్ ఫామ్ లోకి కన్వర్ట్ చేయాలి. సో ఇన్ దిస్ కన్వర్షన్ ప్రాసెస్, so the answer for this is, let us try to make so those statements are propositions. Now here we will be identifying let P as let the proposition P be it is raining, because you can see from here there are two statements that were available, two propositions. So and we will be assuming as the ground is wet. The ground is wet. Now from this, if you see in the logical connectives, we have already discussed various forms of the logical connectives. In that, if you see, if then, whenever we have the statements like if then, then that comes under the P implies Q. So P implies Q. So now if you the same like the sentences, if you try to convert here, now the sentences is, if you convert into logical form, so if you try to convert, so it is raining, like then, like if then, if and then indicates that as in logical connectives we say it is implication. So now, so therefore P implication Q is the logical form of the given sentence. So if P is a statement, if it is raining, then the ground is wet. So this is the way we have to convert the given sentences into the logical form. Next one is, let us try to discuss. సో ఇక్కడ రెండు ప్రీవియస్ ప్రాబ్లమ్ ఇక్కడ రెండు స్టేట్మెంట్స్ ఉన్నాయి కాబట్టి రెండు స్టేట్మెంట్స్ గా డివైడ్ చేసి మనకు ఇఫ్ దెన్ సెంటెన్సెస్ వస్తే దాన్ని మనం ఇంప్లికేషన్ గా డిఫైన్ చేసాం. సో దిస్ ఇస్ ఇంప్లికేషన్ పార్ట్. సో ఇంప్లికేషన్ discuss about the problem now. Determine the determine the truth value of the compound proposition P disjunction negation Q where P is true and Q is false. So they have given when P is true from the question. So ఇక్కడ మనం ఏం చేయాలంటే ట్రూత్ టేబుల్స్ ని ఐడెంటిఫై చేయాలి. అది ఎలా అంటే ఈ P disjunction Q యొక్క negation Q disjunction యొక్క ట్రూత్ వాల్యూ రాయాలి, కనుక్కోవాలి. So to find that we will be let us say they have given what they have given from the question. If you see they have given the statement P is true and the statement Q they have given as false. Now let us try to calculate, because in this question we have to identify the compound proportion P disjunction negation Q value. So to do that, before that we should know that this individual values. So now we already calculated the P value. Now we need the negation Q value. The negation Q becomes true now. And similarly, next we can take the entire compound statement. So P disjunction negation Q. Now we have to recall the properties of the disjunction. So what it does is disjunction properties. So the disjunction properties are whenever the statement P is, the first statement is false and the second statement is also false, then the results will be false. So now, according to this question, the compound proposition that we have to consider as P disjunction negation Q. So now the P is this one and negation Q is this one. Now if you try to map up this, so what we'll be getting? True. Sorry, this is not disjunction, conjunction actually. Sorry. So T conjunction, like let us say this is like this one, disjunction negation P. So when we have a T disjunction negation P, so what we'll be getting as P disjunction. This is actually not. So P disjunction negation P is according to this statement. We have to get when the first statement is false, next statement is false, then only false. But here we are having true. So we'll be getting here true only because it doesn't follow the disjunction of the statement proposition defined as we defined them. Similarly, we can also calculate P disjunction negation P, or we can also, like from the same question, we can also derive various questions. So now we can also have here P disjunction negation P, also negation P disjunction Q. Also, we can also try to calculate P disjunction negation Q. Negation P disjunction negation Q. So let us see these results also. Now, if you try to calculate them also, what will happen is, so the initially the resultant is initially let us try to calculate the next one, conjunction one. So in the same question, if you try to calculate the conjunction, like the given statement they have given as P as true and Q as false, right? Then if you try to calculate this P conjunction negation Q, if you want to calculate this, we need negation Q also. So we have to calculate separately negation Q value. So if you try to calculate negation Q, you will be getting T. So now if you try to calculate P conjunction negation Q, if you try to calculate, we will be getting T. What is the property of conjunction? The property of conjunction is here. The conjunction property is when the first statement is true, second statement is true, then the result also will be true. So accordingly, now the given company statement, the first statement is P and second statement is this. So when both are true, then T. So this is the conjunction property. So that they have given. Right? So this is the way we have to calculate the truth table. That means when we can write in the theory also, like when P is true, and Q is false, then P disjunction negation Q is true. So similarly, we can also derive other problems, like let us say we'll also try to calculate the other one in this. Like if I ask you to calculate this second one and this is first one, and the same. If I ask you to calculate P negation P disjunction negation Q, and next one is you can also calculate negation P conjunction Q. So let us see what will happen. So here the same way, like they have given P and Q in the question. So when P is true, Q is false, right? So while P is true, when P is true, Q is false. But here, if you see, here we have a negation in both the propositions. So first we have to calculate the negation of the proposition, then we can apply the compound proposition for this. So negation P and negation Q, we calculate here. So the given statement is true. So opposite of that is we will be getting false. Similarly, Q, the negation of this is true. Now the property of disjunction is negation P, disjunction negation Q. We have to apply. So if you calculate this as per this disjunction property, we will be getting F is equal to F. So but here the first property is from this we have to take now from here to this two, right? The first statement is false, but the second statement is true. So the result will be now we will be getting the result as true. So similarly, if you write in terms of P, like when P is true, and, Q is false, the result will be then negation P, disjunction negation Q is true. Because when you see this, like these are the way like where logical connectors usually it plays an important role whenever you use some kind of logic in the system, like in the electric circuits and all. Most of the time we use this kind of things. So similarly, we can calculate other one. So now the fourth question is, let us see the question. Sorry, we will also discuss in Telugu language. So if you see here, what we have done, ఏం చేసామంటే, సో ఇక్కడ మనకి ఇచ్చిన స్టేట్మెంట్ లో మనం కాంపౌండ్ స్టేట్మెంట్ ని ఎక్కడ ట్రూత్ వాల్యూ కనుక్కోవాలి. ఆ ట్రూత్ వాల్యూ కనుక్కోవడానికి మనం ఏం చేసామంటే ఇచ్చిన డేటా నుంచి సో కాంపౌండ్ స్టేట్మెంట్ లో ఏదైనా సపరేట్ టర్మ్స్ ఉంటే వాటిని సపరేట్ గా క్యాలిక్యులేట్ చేసి తర్వాత రిజల్ట్స్ దాకా కంప్లీట్ కాంపౌండ్ స్టేట్మెంట్ యొక్క ప్రపోజిషన్ వాల్యూ కనుక్కోవాలి. సో సిమిలర్లీ అన్నిటికీ అలాగే అప్లై చేస్తాము. సో కంజంక్షన్ అంటే జనరల్ గా ఫస్ట్ స్టేట్మెంట్ ట్రూ అండ్ సెకండ్ స్టేట్మెంట్ ట్రూ అయితే దెన్ ద రిజల్ట్స్ ఆల్సో ట్రూ అవుతుంది. డిజంక్షన్ అంటే ఫస్ట్ ఫాల్స్ నెక్స్ట్ ఫాల్స్ అయితే దెన్ ఫాల్స్. సో సిమిలర్లీ డిస్కసింగ్ నెక్స్ట్ ప్రాబ్లమ్స్. So now, yeah, the problem for the construct the truth table for the proposition negation of P disjunction Q. So if you try to calculate truth table for this, so initially we try to calculate the individual proposition values. So usually when we have two propositions, the possibilities are 4. So they are the first statement may be true TT and false and true false and false true. And now a compound proposition, if you want to calculate that there, initially we have to calculate P disjunction Q, and then next we can apply for negation of the P disjunction Q. So initially let us calculate P disjunction Q. So if you try to calculate P disjunction Q, disjunction property is first statement is false, second statement is false, the results also will be false. Then and rest of the cases it is true. Okay. Similarly, if you try to apply negation of P disjunction Q, if you see a negation of this, we're getting false, true, sorry, opposite of this, right? So we'll be getting false, except this case, and rest of the cases we will be getting false, true, false, opposite of negation of this property we have to take. So this is the way we can calculate. Even they ask us to calculate some other terms like negation of P conjunction Q. So let us try to calculate P. Here it's a negation of P conjunction Q. So now the conjunction property is TT is equal to T. Simply we can recall this. So now the like P disjunction Q we already had. So for this we have to apply. Now first calculate P disjunction Q and then we can apply negation of that. P disjunction Q if we calculate here. So only in this case we will be getting true and the rest of the cases will be getting false. Okay. So if you apply for this negation of P disjunction Q, we will getting false, true, so this is the way one can calculate the various truth tables. Okay, as per the SR University dissertation topics. And here another important thing is that here we have discussed about only conjunction and disjunction, but we also have some more problems on the implication and by implication. So that's clarity about this. And another thing is like we have only two propositions here. So when we have two propositions, we have four. But if you have three propositions, we will be having the another proposition R. So in that case, we will be getting the probability for 8. Now, similarly, we will also discuss next set, another set questions. So that if you see, as per the SR University syllabus. Okay. So we had the question as set 2, the problem 1 as set 2, the problem 1 as express the statement, all students passed the exam. All students passed the exam using predicates and quantifiers. Using predicates and quantifiers. Now if you see here, so ఇక్కడ మనం ఏం చేయాలంటే ఈ గివెన్ స్టేట్మెంట్ ని ప్రెడికేట్స్ అండ్ క్వాంటిఫైర్ యూజ్ చేసి స్టేట్మెంట్ ని లాజికల్ కనెక్టర్స్ లోకి కన్వర్ట్ చేయాలి. సో ఇక్కడ మనకి the domain like the given statement లో all students passed the exam. Statement మనకి ఇచ్చిన స్టేట్మెంట్ ఏంటంటే all students passed the exam. So now let us assume the proposition p of x as follows. P of x is, we are assuming as student x passed the exam. Student x passed the exam. So if you want to define like then if you want to define this one in terms of logics and logical connectives and quantifiers form. So for all students, like let us say when we define student x now, so this has to apply for all. So now for all students of x, for all student x, then the students x and x passed the exam. So here for all is the quantifier actually. So quantifiers are, there are different kinds of quantifiers are universal and existential quantifier where basically we define overall. So when you say the for all, it will be like universally we are defining something. So now, so this if you try to convert in the symbolically, so we'll be getting for all students x, for all student x, p of x. So that means this we are converting in terms of the combination of the quantifier and by using the predicates. So ఇక్కడ మనం ఏం చేస్తామంటే వాళ్ళు ఇచ్చిన స్టేట్మెంట్ ని క్వాంటిఫైర్స్ అండ్ ప్రెడికేట్స్ యూజ్ చేసి మ్యాథమెటికల్ సింబల్ ని కన్వర్ట్ చేయడానికి ట్రై చేశాం. సో ఇక్కడ ఆల్ స్టూడెంట్ పాస్ ద ఎగ్జామ్ మీన్స్ అంటే స్టూడెంట్ ఎక్స్ అనే అతను వీఆర్ డిఫైన్ బికాస్ వీఆర్ డిఫైనింగ్ ఫర్ దిస్ universal quantifier. So universally when we define something, we have in mathematics we can use the for all as a universal quantifier. So by using this for all x, so like for all x, like usually for all x and x pass of the exam. So for all x, p of x. Meaning that so p of x is student x and x is the pass of the exam. So here student x pass of the exam. So we define for all students p of x means meaning that all x is the student. So for all students pass of the exam. So that's it. Now define this. Second one, second question. Okay. The second question is like translate the following. Translate the following to following statement to symbolic logic. But as the statement is given as John is tall and Mary is not short. So ఇక్కడ ఇచ్చిన క్వశ్చన్ స్టేట్మెంట్ ని మనం సింబాలిక్ ఫార్ములాకి కన్వర్ట్ చేయాలి. సో కన్వర్ట్ చేయాలి అంటే ఏంటంటే మనకి ఇచ్చిన దాని ప్రకారం సో ఇక్కడ మనం చెక్ చేస్తే మనకి దేర్ ఆర్ 2 స్టేట్మెంట్స్ ఉన్నాయి. సో మనకి ఒక ప్రపోజిషన్ కూడా కనెక్టివ్ కూడా యాడ్ అయింది. సో ఇది దిస్ ఇస్ కనెక్టివ్. సో ఇది కనెక్టివ్. దిస్ ఆర్ 2 propositions we have. So here another connective is negation connective also. We also have a negation connective from the question. If you identify there is a one is connective, one connective is on and another connective is not. So now if you try to apply, like we try to assume these things as something like let us assume t of x, right? T of x, where t of x meaning is t of x is meaning is t of x means we are assuming x is top, x is top, and similarly we also assume s of x meaning that means s of x means x is short, x is short. So now let us construct like if you see John, you can say J as John, and Mary, M is Mary, M as Mary. So now if you try to convert this into symbolic form, we will be getting like from the statement, if you say John is a tall, so that means the tall will come in front actually, right? Therefore T of, instead of x, we will be getting here T of x meaning we are writing x is a tall, S of x meaning is x is short. So now instead of x we have to replace these two things, and short, instead of short we can replace this m. So if we try to do that, we will be getting T of j, and this nothing but we will be defining conjunction, right? And conjunction and instead of Mary, because this is related to short sentence, so we will be writing here generally. We will be, instead of short we will be getting Mary, m of s, sorry, s of m, sorry, s of m will get, because instead of x m we are writing Mary. The meaning is x is short means if you write s of m here, same way if you try to substitute here, if I try to substitute T of j, what is the meaning of T of j? T of j meaning is j is tall. J is nothing but here John is tall. So similarly s of x is here. If you convert this into s of m, so what is the meaning of this? M is short. So M is here as per our assumption is M is Mary. Mary is short. So if you convert this into symbolic logic form, so here we also have another proposition as a negation proposition. So we can write negation of short. Short means here s of Mary is short, right? Mary is not short. So s of m. So now we have converted in terms of symbolic logic. సో ఇక్కడ మనం ఏం చేసామంటే ఇచ్చిన స్టేట్మెంట్ లో జనరల్ గా టీ ఆఫ్ ఎక్స్ అంటే దాని మీనింగ్ ఏంటంటే ఎక్స్ ఇస్ టాల్ అని. అలాగే టీ ఆఫ్ ఎక్స్ ప్లేస్ లో మనం జేని రీప్లేస్ చేస్తే మనం జే అనేది జాన్ అనుకున్నాం, ఎం అనేది మేరీ అనుకున్నాం. సో ఇప్పుడు దాని ప్రకారంగా మనం అజంప్షన్ ఎక్స్ ప్లేస్ లో జేని రీప్లేస్ చేస్తే ఏమవుతుంది? జే, టీ ఆఫ్ జే మీనింగ్ ఈస్ ఇన్స్టెడ్ ఆఫ్ ఎక్స్ మనం ఏం చేయాలి? జేని రాయాలి. సో జాన్ ఈస్ ఎ టాల్, అండ్ ఇది ఆల్సో మనకు ఇంకోటి కూడా ఏంటంటే నాట్ అనే నెగేషన్ ప్రపోజిషన్. సో అందుకు నెగేషన్ సింబల్ ఇచ్చి, సో ఈ మేరీ రిలేటెడ్ ఏమనుకున్నాం? ఎస్ ఆఫ్ ఎక్స్ అనుకున్నాం, షార్ట్ అని, సార్ట్ ఆఫ్ ఎక్స్. సో ఎక్స్ ఈ షార్ట్. సో ఎక్స్ ప్లేస్ లో మనం ఎస్ ఆఫ్ ఎం రాసాం. ఎం అంటే మేరీ ఈ షార్ట్. సో మనకి ఇక్కడ మేరీ షార్ట్ అనేది ఉంది. బట్ ఇక్కడ ఈ కనెక్టివ్స్ ఏదైతే కనెక్టివ్స్ ఉన్నాయో ఆ కనెక్టివ్ అదే నెగేషన్ కనెక్టివ్ ని మనం యాడ్ చేసి ఇచ్చాం. సో దిస్ ఇస్ ద సింబాలిక్ లాజిక్ కన్వర్ట్ చేయాలి. We'll see for the next questions. Now, if you try to look at next question, the next problem is identify the following sentence, which of the identify the which of the following sentences is a proposition, so ఇక్కడ చెక్ చేసుకుంటే the solution. So the first question they have given us 4 plus 7 is equal to 12. 4 plus 12, 7 is equal to 12. It is a declarative arithmetic statement. Actually, it is a declarative arithmetic statement. So it is 4 plus 7 usually 11. So we'll be getting 12 means that is false statement. The statement is false means proposition meaning is either should have the truth value either true or false. So we have false truth value. So it is a proposition. Now the second question is, let us see what are you doing. Let's take question as they have given what are you doing. What are you doing? So now you see here what are you doing. Now here if you see we do not have any kind of మనకి ఇక్కడ స్టేట్మెంట్ ఎటువంటి ట్రూత్ వాల్యూ లేదు. సో కాబట్టి ఇది దిస్ ఇస్ నాట్ ఏ ప్రపోజిషన్. ఇదర్ అర్థమెటికల్ కానీ ఈవెన్ నాట్ ఏ ఇట్ ఇస్ నాట్ ఏ ప్రపోజిషన్. ఇట్ ఇస్ సెంటెన్సెస్ ట్రూత్ వాల్యూ లేదు. సో నెక్స్ట్ థర్డ్ వన్ వచ్చేసి 3n is less than or equal to 81 and they have given n belongs to n. సో ఇక్కడ ఇన్ దిస్ స్టేట్మెంట్ మనకి ఇక్కడ n వాల్యూస్ అన్నిటికీ ఓపెన్ సెంటెన్స్ గా ఇచ్చేస్తారు. సో ఇన్ దిస్ సెంటెన్స్ ఇఫ్ యూ సీ n does not fixed act. So that meaning that we do not have any kind of truth value. If until unless if you know n value exactly what it is, then we can say we'll have something like can say that it is true or false. But until unless we just say generally, so it is actually like we do not have open sentence. Actually, it is also an open sentence kind. We do not have a closed forms of sentence like exactly fixed values of n. So therefore, this also not a proposition. And next question is you see ఈ n వాల్యూ ఇక్కడ అబ్జర్వ్ చేశారంటే ఈ n వాల్యూలో మనకి ఫిక్స్డ్ వాల్యూస్ లేవు. అంటే n is equal to 1 2 3 అలా ఉన్నప్పుడు మనం చెక్ చేసి చెప్పొచ్చు. సో వీ హ్యావ్ అ ట్రూ ఫాల్స్ అని. బట్ n ఇది కూడా ఓపెన్ సెంటెన్స్ జనరల్ స్టేట్మెంట్ గా ఇచ్చారు. సో మనం ఎగ్జాక్ట్ గా ట్రూత్ వాల్యూ ఉంది యూ కెనాట్ గివ్, మనం చెప్పలేము. సో కాబట్టి ఇది నాట్ ఎ ప్రపోజిషన్. సో సిమిలర్లీ next question is peacock is our national bird. So ఇది మనకి like there may be like either it is a true or false. Like we have exactly like some proposition statement, right? They have mentioned peacock is our national bird. If it is true we say true, if it is false we say false. So it has a fixed truth value, so it is true usually. So therefore it is a proposition. So similarly So the next question we'll discuss about it. మనకి ఈ సెంటెన్స్ పికాక్ ఈజ్ నేషనల్ బర్డ్ అనే సెంటెన్స్ లో మనకి ఎగ్జాక్ట్ గా ఒక ట్రూత్ వాల్యూ వస్తుంది కాబట్టి సెంటెన్స్ నుంచి మనం చెప్పగలం కాబట్టి సో దెన్ ఇట్ ఈస్ then we are saying it is a proposition. Proposition is very simple. Like if you have, we just have to remember if any sentence has the truth value, it may be the false or true, but both should not be both. It can be both. Then we say that it is that you should not have some kind of confusion state also. Then only we say that it is a proposition. In the next problem, construct the truth table. Construct the truth table for P implies Q, disjunction Q implies R. సో ఈ ట్రూత్ టేబుల్ మనం ఇక్కడ ట్రూత్ టేబుల్ కన్స్ట్రక్ట్ చేయాలి. ఈ టేబుల్ ని చెక్ చేసుకుంటే మనకి 3 స్టేట్మెంట్స్ ఉన్నాయి. అది P, Q and R. So there are 3 propositions or statements. So when we have 3 propositions or statement, the possibilities are 8 actually. So what are they? We will just note them down. So P, Q, R. So when T all may true, all may be, the possibilities are all may true, and which we will try to write all different possibilities and then we try to calculate the solution. So now when we have a 3 proposition, the possibilities are as follows. The possibilities is time T, and we'll also have TTF, next TF, T, then T. The same way, we will also have in terms of false statements, right? So similarly, we will also have here, then here, T, next here, T, here, and then the last one is we will also have another possibility as here, TFF. So this is the way we will be getting all 8 possibilities. Now you see we have a combination of the compound statements. So we will try to calculate, like we will be using in the Bartmas limit, the bracket values we will be calculating initially, and then we will apply entire compound statement value, proposition value. So now if you try to calculate here, P implies Q, we have to calculate separately, the bracket value separately. Also Q implies R, also we have to calculate. Then P implies Q and Q implies R. So this statement is better calculate చేస్తుంది. సో ఇక్కడ P implies Q అంటే implication property ఏంటంటే మనకి even we have 3 properties, we will apply the properties that we defined here. ఇక్కడ ఏదైతే ఉందో వాటికి మాత్రం అప్లై చేయాలి. సో ఇక్కడ చేస్తే ఇంప్లికేషన్ ప్రాపర్టీ ఏంటంటే ఇప్పుడైతే మనకి T F is equal to F. సో ఫస్ట్ స్టేట్మెంట్ T F ఉంటే and next statement F అవుతుంది. ఇది ఇంప్లికేషన్ ప్రాపర్టీ. అప్లై చేస్తే P కి Q కి చేస్తున్నాం కాబట్టి TT is T, ఓన్లీ TF ప్లేస్ లో మాత్రమే మనకి F అనేది వస్తుంది. సో రిమైనింగ్ కేస్ లో T నే వస్తుంది. TT almost all T's will get. So here also we will be getting, here also we will be getting T, TF. So we will also have here TF. So in this place also we will be getting false actually. TF is false. So the same way we can also calculate Q implies R. ఇక్కడ మనకి ఏం చేస్తామంటే ఇంప్లికేషన్ ప్రాపర్టీని అప్లై చేసి, ఇంప్లికేషన్ ప్రాపర్టీ అంటే ఫస్ట్ స్టేట్మెంట్ కి ఫాల్స్ ఈజ్ ఈక్వల్ టు ఫాల్స్ అవుతుంది, రెస్ట్ ఆఫ్ ద కేసెస్ లో ట్రూ అవుతుంది. సో సేమ్ వే ఈ టూ కాంపౌండ్స్ చెప్పి సపరేట్గా కనుక్కుంటాం. Q implies R అంటే Q implies R ఈ రెండింటికి TF is F. So in the next place where we have TF, so there is another case here, TF is F. So now the rest of the cases we will be getting T, 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 T. So now we have to apply combining these two, right? So now if you try to apply both combine, so we will be getting as combine. The command is like Q implies Q and Q implies R. So that is P implies Q we calculated here, Q implies R we calculated here. Now we have to apply the connective is here and so unconnective property is TT is equal to T. So ఇక్కడ మనం కాంపౌండ్ వాల్యూ ఎంటర్ వాల్యూ కనుక్కున్నాము. సో ఈ బ్రాకెట్ వాల్యూ సపరేట్ గా కనుక్కున్నాం కాబట్టి సో వాటికి కంబైన్డ్ గా అండ్ కంజంక్షన్ ప్రాపర్టీని అప్లై చేస్తాం. సో అది అప్లై చేస్తే ప్రాపర్టీ TT ఈజ్ ఈక్వల్ టు TT అయితే T అవుతుంది. సో ఇంకా TT అయితే T అవుతుంది, TT అయితే T అవుతుంది. సో ఇక్కడ కూడా T అవుతుంది. ఇంకా రెస్ట్ ఆఫ్ ద కేసెస్ లో ఫాల్స్ అవుతుంది. The rest of the cases it is. So this is the way one can calculate the truth table for the more than three propositions will be have. Similarly, so we will also look at one more set solution. One that is like you can see here another set solution. Yeah. So now if you see the next solution set, in that we have the question as translate into the predicate logic. The sentences is there exists a student who likes both math and science. Who likes both math and science. So ఈ సెంటెన్స్ ని మనం ట్రై చేయడానికి కన్వర్ట్ ట్రై చేస్తే మనకి ఏమవుతుందా అంటే సో ఇక్కడ మనకి ఫస్ట్ ఈ సెంటెన్స్ లో ఉన్న we have to use both connectives as well as quantifiers. So we have there existential quantifier. We have one is universal and there exists means it applies for only single student. So now we are assuming that therefore let us say m of x meaning that we are assuming is x likes math. So and now s of x meaning that x likes science. Similarly we defined earlier also the same way. So now earlier we have universally we defined for all, but now we are defining their existential quantifier means only the particular student. So in the existential quantifier we will be applying for only the single student. So now the sentence they have given as there exists a student who likes both math and science. Now if you try to convert this into the logic form, predicate logic form, there exists a student AX who likes and we also need to can use some connective to combine these two because we have unconnective here. So we have to use unconnective. We will be representing it here in terms of conjunction. So that conjunction is nothing but and actually. So there exists a student X who likes math means m of X. And here we have and not R, right? So we have R, then we have to write R connective. So now we have unconnected. So we are writing and there exists S of X. So this is the way we have to look at it. మనం చేస్తామంటే ఎర్లియర్ గా మనం ఇంతకు ముందు ప్రోగ్రామ్ కూడా డిస్కస్ చేసినప్పుడు m of x అంటే we are assuming ఇక్కడ మనం assume m of x అంటే x likes math అనుకుంటున్నాం. Similarly x likes science అనుకుంటున్నాం. సో ఇక్కడ ఏంటంటే there exists a x. M of x means maths and science both. Like x అనే స్టూడెంట్ he likes both maths and science అని represent చేసాము. So next the next question you see here. Next second is next question is express the contrapositive of implication. Contrapositive of implication. Contrapositive of implication. The statement is if it snows, then school will be closed. Then school will be closed. So we have the contrapositive statement here. The contrapositive is nothing but we have to take the opposite of the given statements actually. So now if you see clearly here, in contrapositive sentence contrapositive of the implication convert చేయమని అడుగుతున్నారు. సో ఇక్కడ మనం సెంటెన్సెస్ లో వాటికి టూ ప్రపోజిషన్స్ డివైడ్ చేయాలి. అంటే he will be it snows. Then Q will be schools will be closed. This Q statements. So now if then we have again the sentences. If you see here, if then we have if then definitely we will be applying implication, but here we have to apply the contrapositive of the given statement. Contrapositive means the reverse actually. So that means in the words, if you try to write here, if the school is not closed, because the school will be closed, the contrapositive is opposite of this is school is not closed, then it did not snow. Same sentence we are writing did not, because this did not represent the contrapositive. This contrapositive of the given statement is this one. So this is the way we have to write. Now if you try to represent that into in terms of symbolically, like if you see the express, you will be getting negation Q means if Q is nothing but here the school is not closed, implies then this is implies here then it did not show, it didn't show. Negation P is it shows snows, and negation P means it did not snow. Negation So we represented in terms of logical connective and connective symbolical logical way also represented. ఇక్కడ మనం ఏం చేసామంటే టూ సెంటెన్సెస్ తీసుకొని వాటిని సపరేట్ చేసి, సో పి అంటే ఇట్ స్నోస్ అనేది క్యూ అంటే స్కూల్ విల్ బి క్లోజ్డ్ అనుకున్నాం. సో ఇక్కడ contrapositive అంటే ఆపోజిట్ ఆఫ్ దిస్ స్టేట్మెంట్ తీసుకోవాలి. సో దాని ప్రకారం చెక్ చేస్తే ఇక్కడ స్కూల్ అనేది నాట్ క్లోజ్డ్ ఎప్పుడంటే అది స్నో లేనప్పుడు క్లోజ్ చేయమని. Another two problems if you try to discuss here. Let us see now. There was another problem here. If you see in the problem 3, we had in this another set. Problem 3 as determine the truth value of P implies negation Q where P is true and Q is false. So therefore the solution for this is like as we already discussed. So we will know with a little speed. So as we know, they have given P as a true and Q is false. Now if you want to calculate this compound proposition, the terms that are there we will be calculating separately. So that is nothing but negation Q value. The negation Q is we will be getting true. Then P implies negation Q value is now P implies negation Q values. So the implication property P and negation Q you remember to apply actually. So implication property is TF is equal to F and rest of the cases. So if I check this, the TT is equal to we'll be getting TF. So negation Q value property. So we'll be getting true. So sentences, if you try to write into terms of sentences, we will be getting when P is true and Q is false. P implies negation, Q is similarly. If you try to discuss the last problem on this. So the problem is now here we have been next problem. Construct the truth tables for P implies Q by implies negation P, negation Q implies negation P. సో ఇప్పుడు చేస్తే PQ స్టేట్మెంట్స్ మనకు ఉన్నాయి. సో ఈ PQ స్టేట్మెంట్స్ ఉన్నప్పుడు మనకు పాసిబిలిటీస్ ఆర్ TT, FF. Similarly, two possibilities are సో మనకి టూ ప్రపోజల్స్ ఉన్నప్పుడు పాసిబిలిటీస్ అంటే 4 వస్తాయి. TF అండ్ FT కూడా వస్తాయి. సో ఈ కాంపౌండ్ స్టేట్మెంట్ సెపరేట్ కనుక్కోవాలి కాబట్టి ఫస్ట్ P implies Q కనుక్కున్నాం. P implies Q and negation Q and negation P and also we need negation P Q implies negation P separate గా కన్సిడర్ చేసి తర్వాత లాస్ట్ దిస్ ఎంటైర్ రిజల్ట్ వాల్యూస్ ఇక్కడ. సో P implies Q అంటే TF is equal to F and rest of the cases T. సో ఇంప్లికేషన్ ప్రాపర్టీ అప్లై చేస్తే మనకి TF P ఫస్ట్ స్టేట్మెంట్ ట్రూ అండ్ సెకండ్ స్టేట్మెంట్ ఇస్ ఫాల్స్ అయితే మాత్రమే ఫాల్స్, రెస్ట్ ఆఫ్ ద కేసెస్ ట్రూ అవుతుంది. అండ్ నెగేషన్ Q అంటే ఫాల్స్, ట్రూ, ట్రూ అండ్ ఫాల్స్. అండ్ నెగేషన్ P is false, true, false, true. And negation Q implies again ఈ రెండింటికి ఇంప్లికేషన్ ప్రాపర్టీ అప్లై చేయాలి. సో ఇక్కడ TF is equal to F అవుతుంది అండ్ రెస్ట్ ఆఫ్ ద కేసెస్ లో ట్రూ ఇంప్లికేషన్ ప్రాపర్టీ. సో నెక్స్ట్ బై ఇంప్లికేషన్ ప్రాపర్టీ ద ఎంటైర్ టర్మ్ కి క్యాలిక్యులేట్ చేస్తే P implies Q by implies negation P implies negation Q implies negation. We have calculated separately these two terms and this one and this one, and this one. So P implies Q here, negation Q implies negation Q is here. So now if you try to map this, we have now here by implication property is, so when we have a by implication property there are two conditions like FF is equal to also implication property ఏంటంటే both false అయినా true అవుతుంది, both true అయినా true అవుతుంది. So if you see here now we have to apply for this one and this one. So these two both are true, then the results also will be true. Then this also both are true, then the results will be true. If both are false also we have true. And both are true also we have a true. So if you observe here, in the last column we have all these. So when we have all two trees in the component statements, then we say that these are tautology. And this will be discussed in coming recitations. Thank you.